All right, kidlets, we are going to solve this system using elimination. And so I am going to, first, what we do is we are trying to eliminate one of the variables so that we have a two-variable system. And we do that using two sets of two equations each. So I look at this and I've got three equations here. And I want to eliminate one of these variables, and as I look at this, I see that I have two just alone y's here, okay? And so what I want to do is I'm going to take those two equations and I'm going to eliminate y from both of those equations. So I'm going to take this set of equations right here. And I'm going to, I'm just going to rewrite the set down here so that I can modify them. So this is 5x plus y plus 2z is equal to 10. And then 3x plus y minus 8z is equal to negative 28. Now I've got two y's, but they're both positive. So if I added these two equations together right now, I get 2y. I don't want to do that. And so I'm going to multiply this bottom equation by negative 1 so that one of the y's would be positive and one would be negative. And so when I do that, I get the same equation on top, the 5x plus y plus 2z is equal to 10. And then the bottom equation becomes negative 3x minus y plus 8z is equal to 28. And when I combine those, I get a new equation. All right, so I'm going to add them together at this point, and I get a new equation. And that new equation is 2x plus 0y plus 10z is equal to 38. And so that is just 2x plus 10z is equal to 38. And notice that the y is gone. It's completely gone. And that's what we want. That is one of our two equations that we are going to use later on to eliminate another variable. Okay, so we have to do that twice. I have to pick another set of equations to use elimination on. And when I'm looking at these equations, I think I'm going to pick the first two. Now, we only have three equations, and so we have to reuse one of the equations, but you can only reuse one of them. You can't reuse both. So I'm going to eliminate using these first two equations now. So this is 2x minus 6y plus 9z is equal to negative 8. And this is 5x plus y plus 2z is equal to 10. And I'm going to eliminate the same variable. It's very important that you eliminate the same variable. And so I'm looking at this and I need to eliminate y because that's what I eliminated from the other set of equations. I've got a negative 6y here and just a 1y there. If I add these together, I get negative 5y. That does not help. So I need to make this y into something that will eliminate when combined with a negative 6y. And the way I do that is I multiply by 6. And so the top equation stays the same. It's 2x minus 6y plus 9z is equal to negative 8. And the bottom equation becomes 30x plus 6y plus 12z is equal to 60. And I'm going to add those two equations together. And when I do, you'll see that the y's cancel out. So I'm going to add them together. When we add them together, we get 32x plus 0y plus 21z is equal to 52. And so this is just 32x plus 21z is equal to 52. Those are some big numbers, but we can work with them. So what we're going to do now, guys, is we're going to take this equation here, this 2x plus 10z, and this equation here. They're both two variable equations, and they're the same two variables. And what I can do is I can then use those to do elimination and solve for just one variable. So I'm going to take these two equations, the 2x plus 10z is equal to 38, and the 32x plus 21z is equal to 52. And I'm looking at this And I'm thinking that it is probably easier to eliminate x, and that's because this is a 2 and that's a 32. 10 and 21 don't have a lot of numbers in common. But I can easily make the 2 into a 32. I have to multiply by 16. And so what I'm going to do is I'm going to multiply this top equation by negative 16. Don't be afraid of having to do that, guys. Numbers are numbers. I know sometimes it stresses you out when they get big, but don't worry too much about it, okay? So this is going to be negative 32x minus 160z is equal to, we're going to use the calculator for this just to make sure I don't mess up since we're recording. It's negative 608, negative 608, okay? That is our first equation. Our second equation didn't change, so this is 32x plus 21z is equal to 52. And what we're going to do is we're going to add those two equations together. We get 0x minus, this is 139z is equal to negative 556. And so what we have now, guys, negative 139z is equal to negative 556. What we have now is an equation that only has one variable. And so we can solve for that variable by dividing by negative 139. And when you divide by negative 139, you get z is equal to 4. And so what we have now is a numeric answer. And this is fabulous. So I've got one of my solutions right here. Way to go, us. And then what you're going to do is you're going to work your way back up using the other equations to find the other variables. So I'm going to use this equation right here, the 2x plus 10z equals 38, and I know that z is 4, so I'm going to use this equation to solve for x. So if I've got 2x plus 10z is equal to 38, I know that z is 4. And so this is going to be 2x plus 10 times 4 is equal to 38. 2x plus 40 is equal to 38. Subtract the 40. I get 2x is equal to negative 2. Divide by 2. X is equal to negative 1. And that is our second variable. Now we have two variables, which is super awesome and exciting. And what we want to do with those two variables is we want to go back to one of our three original equations and solve for the third variable, which is y. And so I'm going to use the middle one. Either one of these is easiest. Any equation works, but I like the red and the blue one because they're just alone y's. But I'm going to go back, I'm going to use the red one. So the 5x plus y plus 2z is equal to 10. And I know that z is 4. Draw an arrow here. There we go. And that x is negative 1. There we go. So this is 5 times negative 1 plus y plus 2 times 4 is equal to 10. This is negative 5 plus y plus 8 is equal to 10. Combine like terms, negative 5 and 8, that's 3. So y plus 3 is equal to 10. Subtract the 3, you get y is equal to 7. And so our solution to this system right here is x equals negative 1, y equals 7, and z equals 4. And the way we write that solution is an ordered triple, right? And so it's negative 1, 7, 4, like that. This is how you solve a system of three variables using elimination. This problem is also on your notes. So go ahead and, read through it again, watch the video again if you need to, and then work on your assigned problem.